PQRS is a parallelogram. And we draw out first to make it easier for us. PQRS. Make sure you go round it in order. In which PS is 6 and SR is 10. The area of this is 20. Now, I'm going to split that into two triangles. The area of that is 20. Each triangle has an area of 10. And the area of a non-right angled triangle is a half AB sine C. So if you look at this wee triangle down here, and I'll draw it out so you can see it a little more clearly. So that's PSR. The area is 10. The two sides are 6 and 10. And the angle between them is S. So working this out, 60 divided by 2 is 30. So you have 10 equals 30 sine S. Bring that over, divide. So a third equals sine S. Bring this over as inverse. So inverse a third equals S. So inverse sine 1 divided by 3 gives me my angle. And you're going 6.4. So a ship sails 6.4 kilometres on a bearing of 52 degrees from a port P. So we're starting at P. Until it reaches another position A. So that's A. Another ship sails 9.5 kilometres on a bearing of 135 from P. So I'll put it in a different colour. So 135, that'd be 90, but down here somewhere. Okay, so it's that whole angle there is 135 degrees. Automatically, I want to put that wee angle in here just because I can. So 135 minus 52, that's 83 degrees. Now the other ship goes 9.5 kilometres. So 9.5 to here until it reaches B. Calculate AB. So I am looking for this line here. I'm just going to draw my triangle out so I can see it a little clearer there. But something like this. A, B, P. 83 degrees, 6.4, 9.5. Two sides and in between angle, it's going to be cosine rule. And I want AB. So remember, you start with this side, you finish with this angle. So AB squared equals the other two sides squared minus 2 times the other two sides times cosine the angle. And remember, you do these in two halves. This half and this half. So AB squared is 6.4 squared add 9.5 squared to give you an answer of 131.21 minus 2 times 6.4 times 9.5 times cosine 83 to give you an answer of 14.8193. So AB squared is 131.21. Subtract my answer to give me 116.39. So AB is the square root of that to give me an answer of 10.8 kilometres. The question then wants the bearing of B from A. So you're going from A, the north sine in, and you're wanting that bearing in there. Now, to help me do that bearing in there, I need to think of how to find a different angle. Now, I'll find this angle in here, A. I can use the sine rule for that. So 9.5 over sine. Now, AB is 10.8 over that angle, sine 83. Fraction equals fraction, you cross multiply. So it's 9.5 times sine 83 equals 10.8 times sine A. Bring that over and divide, just do it all in one go. 9.5 times sine 83 equals, divided by 10.8. So I have got sine A is 0.873. Bring your sine over and inverse sine. So inverse sine 0.873. So shift sign answer gives me the angle 60.82. Now that is not what the question had asked me. I have found this angle in here, 60.82. Now I have to try to find this red line. If I go back to the original diagram, I am trying to find this angle here. Now, I know this angle in A is now 60.82. If you look at the Z shape, you can see that this angle is 52, so this little angle in here is 60.82 minus your 52, so that little angle in there is 8.8177. If I show it in this diagram as well, that means that angle in there is 8.8177. So my red line is going to be 180 minus 8.877. So the bearing equals 180 minus 8.8177. So 180 minus that gives you an answer of 171 degrees. A person at a point A on the ground sees a vertical tower TQ of height 6.8. Now I am not told where A is on the ground. I'm not told it is to the right or the left or east or west. So I'll just put it down here, A. Triangle's a little inaccurate there. Obviously that's going to be a right angle. Where Q is on the ground. Oh, so that's Q. And that's T. The angle of elevation of T from A is 34 degrees. The angle of elevation of T from B, which is another point on the ground, I'll just put B to be here. Now that angle of elevation in there is 41 degrees. The angle AQB is 67. So this angle in here is 67. Find AB. So find the distance between those two. Now if you look at your first triangle, your AQT triangle, AQT, I can find AQ. If you look at your BTQ triangle, so BQT 6.8, and that's 41, I could find BQ. So I'm looking to find AQ and BQ, because then that will give me a triangle along the base, along the ground. So working this out here, hypotenuse, opposite, adjacent, opposite, adjacent. Tan 34 is opposite over adjacent. Bring that across and multiply. AQ is tan 34, 6.8. Bring that across and divide. AQ is 6.8 divided by tan 34. So 6.8 divided by tan 34 gives me 10.1. I'll put in 10.08 because I'm going to be using this in a later calculation just to keep my work accurate. He's going to do the exact same calculation as other triangle. Hypotenuse, opposite, so I know, adjacent, what I want. Tan 41 is opposite over adjacent. Bring your BQ over and multiply. And then bring your tan 41 over and divide. So BQ is 6.8 divided by tan 41. So BQ 6.8 divided by tan 41 gives me an answer of 7.8225. Now if I take the triangle along the ground, the AQB triangle, AQB, you know the angle in it Q is 67. You've worked out AQ is 10.08, BQ is 7.8225, and the question wants AB. Two sides and in between angle is cosine rule. And make sure you start and you finish the opposite angle inside. So AB squared equals 10.08 squared. So add the other two sides squared minus 2 times the other two sides times cosine the angle between them. Do it in 2 halves. So AB squared is, work this one out first. So square that plus 10.08. I had the answer on my calculator, so I just pressed answer squared. Add 10.08 squared. Gives you 162.7979871 minus, and do this all in one go, 2 times 10.08 times 7, hard to see that point there, 7.8225 times cosine 67 gives me 61.6189. So AB squared is 162.7979871 minus my answer to give me 101.179. So AB is the square root of that answer, which is 10.1, and it's in meters.